Good morning all of you. Hydroxy compounds, alcohols. Nucleophilic substitution reaction of primary alcohol. This is second video under this heading. We know primary alcohol is one in which the OH is attached to CH2 or CH3 carbon. Now we take the example of primary alcohol CH3, CH2OH. Functional group undergo chemical reaction we know. When treated with phosphorus trichloride in presence of a base called pyridine gives CH3, CH2Cl. OH minus ion is replaced by Cl minus ion. Actually, how the reaction takes place? It follows SN2 reaction. Ethyl alcohol, 3 molecules of ethyl alcohol. Now I write CH3, CH2OH. Another molecule of ethyl alcohol, CH3, CH2OH. Third molecule of ethyl alcohol, CH3, CH2OH when treated with phosphorus trichloride in presence of pyridine, a heterocyclic nitrogen containing heterocyclic compound. H3PO3. H3PO3. Phosphorus acid is removed. Each one chlorine is added to ethyl gives CH3, CH2OH, ethyl alcohol plus H3PO3. Orthophosphorus acid is removed. Here the OH is replaced by chlorine. 2 carbon eth, carbon single bond N ethane, functional group chloroethane. Each one chlorine is added to carbon atom gives chloroethane. Now I write the mechanism of this reaction. Actually how the reaction takes place. Ethyl alcohol CH3, CH2OH. Whenever we start the mechanism, remember there is 2 pair of electron on oxygen. When treated with phosphorus trichloride PCl3. In the next step, the pyridine used to remove this H+. Now, one chlorine is removed as the negatively charged ion Cl-. We will use this minus in the last step. Because of chlorine is removed as minus, charge on carbon, phosphorus becomes plus. Phosphorus donate a pair of electron, oxygen donate a pair of electron to phosphorus. Thereby a new bond is formed between oxygen and phosphorus. CH3, CH2, oxygen, here you have one hydrogen. One pair of electron is donated to phosphorus, P. It has one chlorine and another chlorine. There is one pair of electron on oxygen and there is a positive charge on oxygen. Now, what is the use of pyridine? Pyridine is a Lewis base. According to a Lewis base, nitrogen having a pair of electron, now nitrogen of pyridine donate a pair of electron to this H+. Remember, you know whenever oxygen donate a pair of electron in the first step, it remove a pair of electron from the nearby step. This H+ is removed, oxygen get its electron. So the structure is pyridine absorb a proton by the donation of this pair of electron. Which one is formed? C6, C5, H5, NH. Here there are 3 double bond and there is one positive charge on nitrogen. Oxygen get a pair of electron. So the molecular formula we have is CH3CH2, oxygen, 2 pair of electron along with the PCl2. Come to the last step. In the first step, you removed one chlorine. Now we are going to add that chlorine. Oxygen get this electron, therefore charge on carbon becomes minus, plus, minus is added to plus gives CH3, CH2Cl, our product is obtained with the loss of O minus PCl2. This is your 2 carbon ethane, carbon-carbon single bond N ethane, Cl chloroethane. This is one of the nucleophilic substitution reaction. Simply remember, ethyl alcohol when treated with the phosphorus trichloride in the presence of pyridine gives chloroethane. OH minus ion is substituted by Cl minus ion. One more reaction. Ethyl alcohol, a primary alcohol, CH3, CH2OH. OH is attached to CH. 2 carbon eth, carbon-carbon single bond N, OH all. When treated with the SOCl2, thionyl chloride, SOCl2, same in the presence of pyridine. A Lewis base, it is used to remove an acid. What happens? We know functional group undergo chemical reaction. At the same time, we are studying nucleophilic substitution reaction. So, OH minus is replaced by Cl minus, 1 H plus and Cl minus removed as HCl. This oxygen combined with the SO and is removed as SO2. This chlorine is added to carbon plus, gives our main product CH3, CH2Cl, chloroethane plus liberation of SO2 and loss of HCl. One more reaction under this nucleophilic substitution reaction with phosphorus pentachloride. Ethyl alcohol, CH3, CH2OH. Ethyl alcohol, when treated with phosphorus pentachloride, PCl5. So, in the above reaction, this HCl is removed by using the pyridine. What happens here? 1 H plus and Cl minus is removed as HCl. H plus and Cl minus removed as HCl. This oxygen combined with the PCl3 and form POCl3. This Cl minus is now added to carbon plus, ethyl plus gives the product CH3, CH2Cl plus POCl3, phosphorus oxychloride or phosphoryl chloride along with the loss of HCl. 2 carbon eth, single bond N ethane, Cl chloroethane. Why here pyridine is used? Because along with the chloroethane there are 2 products are formed. SO2 is a non-metallic oxide, HCl is an acid. Non-metallic oxide or acidic oxide. So this is acidic in nature, this is also in acidic in nature. To remove these 2 products, we used here a base. This base is used to remove these 2 acidic byproducts. 2 carbon eth, carbon-carbon single bond N, OH all ethanol. Okay, so in this video, we discussed about the nucleophilic substitution reaction of OH minus ion by Cl minus ion by using phosphorus trichloride, thionyl chloride and phosphorus pentachloride. In the next video, incoming video, we are going to study the electrophilic substitution, nucleophilic substitution reaction of tertiary alcohol. Thank you for watching. If you like, please subscribe.